Hi everyone. Today we'll be presenting our final project on predicting hotel ratings using big data analytics. Our aim is to uncover what factors contribute to making a hotel highly rated and how we can use this information to benefit the hospitality industry.
Ah,
Um, yeah, slide. Next slide. So our primary objective is to identify key factors that influence hotel ratings using data-driven insights. The project seeks to offer actionable guidance for hospitality companies and travel agencies focused on establishing and managing top-rated hotels. The value of our project lies in guiding these businesses to make informed decisions on where and how to develop their next projects, maximizing both guest satisfaction and profitability. So we utilize two major data sets from Kaggle for our analysis. The first dataset provides detailed information about how hotels worldwide, including amenities, services, and guest ratings. And the second dataset contains data on the locations of city centers globally. By merging these two datasets, we aim to analyze several features such as hotel location relative to attractions in city centers, the number of facilities, and the ratings of nearby hotels to predict overall hotel ratings. Um, so we first looked into how many hotels are located in each country and where in the country. So exploring hotel distribution in the USA, Netherlands, and Belarus reveals insights into market maturity, with the USA and Netherlands having mature, well-developed tourism sectors evident from numerous hotels in tourist-heavy areas, while Belarus shows fewer hotels, indicating a less prominent tourism industry. And this conclusion enhances our understanding of the data set by identifying and correlating the characteristics of hotel distributions with broader tourism and economic trends, allowing us to tailor strategic decisions for hotel placement and marketing based on specific regional demands and opportunities. Next, we looked into the ratings of hotels analysis. The analysis of hotel distributions in the US, Belarus, and Antigua reveals diverse markets, with the USA featuring a broad spectrum of hotels across all star categories, indicative of a mature market with varied service offerings. In contrast, Belarus and Antigua show a concentration of mid-range accommodations, suggesting a market focus on average tourist and valley-oriented services. And the presence of higher star hotels in the USA may signal strong economic support for luxury accommodations, whereas the more limited range in Belarus and Antigua could point to investment opportunities in upscale hotel development if demand exists. And this deeper insight into the data set helps tailor strategic approaches to hotel development and marketing within these varied economic and tourism contexts. So now we want to look at the mean distance from hotels to attractions. So analyzing the distribution of mean distances to attractions help identify a potential correlation between proximity to key attractions and higher hotel ratings. And if hotels closer to attractions tend to have higher ratings, this suggests that tourists value convenience and accessibility, which are important factors to consider in site selection and marketing strategies. So the heat map analysis of hotel locations relative to attractions show that areas with intense red coloring, likely urban centers, have hotels closer to numerous attractions, indicating high-density tourist zones. In contrast, areas with less intense coloring suggest potential underserved markets where there could be opportunities for developing new hotels or attractions. And the clear regional variations highlight the uneven distribution of attractions, with urban areas typically having more concentrated attractions compared to more dispersed rural areas. So now we want to explore the distance from hotel to city center. The analysis shows the mean and median distance of hotels from city centers, which highlights a right skewed distribution. And this indicates that while most hotels are clustered close to city centers, there are significant outliers as well. And finally, we can look at the number of nearby hotels of each star rating. The histograms for each star category offer a quantitative view of the density and distribution of hotels by star rating in various areas. We see that hotels are predominantly located near city centers, with the right skewed distribution indicating that fewer hotels are found at greater distances. Higher star hotels, 3 star and above, tend to cluster together, suggesting areas with higher economic activity and tourist attractions, while 1 star and 2 star hotels are less frequently located near these high tier hotels.
So yeah, that's about the exploratory data analysis, and now we're going to get into the modeling part. So here's a list of features that we engineered from our original data frame and used in our model. So it includes a list of information on the hotel facilities, its distance to some nearby attractions in the city center, as well as a list of information on how highly rated the hotels nearby it are. So we used two major modeling approaches, logistic regression and random forest classification. So this is the performance of a baseline model on the overall dataset. It achieves an overall accuracy of around 69%, and it is basically a dummy classifier that outputs the mode in the target variable for each entry. And then the first model that we use is a simple logistic regression model. It achieves a higher test set accuracy than the training set accuracy, so 75%, which is a pretty good elevation from the baseline model's performance. And also it shows that there is no overfitting because it achieves a higher accuracy on the test set than the training set. So then these are the more detailed metrics that allow us to take a look at some of the issues that happen. So for example, the model achieves a higher precision and F1 score on lower rated hotels, which is the target class majority, than the higher rated hotels, which is the target class minority. So this shows that the target class imbalance in our dataset is affecting our model's performance on the minority class. We used SMOS, which is a oversampling of the synthetic oversampling of minority samples to try to combat this issue, but the issue apparently from the metrics still existed, and as we're seeing a much stronger and robust performance of the model on the target class majority than the target class minority. So to resolve these issues, we try to use hyperparameter tuning to try to further elevate the accuracy as well as resolve this issue of target class imbalance. And as you can see, the accuracy didn't really elevate by that much, around a 75% accuracy overall. And the problem of target class imbalance still existed. As you can see, there is still this inconsistency in the precision on the model's performance on the majority class and the minority class in the target variable. So then we decided to use random forest classification. And random forest classification actually achieves a high elevation in the model's overall accuracy, as it achieves around 80% accuracy on the training set and a 77% accuracy on a test set. But there might be overfitting here because we're seeing a higher performance of the model on training set than test set. And although this problem of target class imbalance effect on the model metrics is improved, as you can see, the gap between precision on majority and minority is lowered, but it still exists. So then we try to use cross-validation to improve the problem of overfitting, but still we're seeing a higher performance on the training set than the test set in terms of accuracy, and the problem of target class imbalance still exists as we're seeing a higher precision on lower rated hotels and higher rated hotels. So now we can take a look at feature importances. As you can see, since random forest classification is an interpretable modeling approach, we can see that number of facilities and the number of good and mediocre hotels nearby are the most important features in our model. So overall, these information gives us a couple things that we can take away from our model. So if you're a property owner, you might really want to consider the number of facilities in your hotel because according to our model, that is the most important thing that determines the rating of your hotel. Also, you might want to take a look at the rating of your nearby hotels because the rating of nearby hotels can determine the rating of your hotel. So there is a correlation that happens there according to our model. So last but not least, you might want to pay attention to these two factors instead of the distance between your hotel to city center and nearby attractions, because according to our model, that matters less in terms of whether your hotel is highly rated or not. So there definitely still are challenges and limitations that we ran into when we were doing this project, and some future works that can be done. So for example, feature engineering is something that we really hope to do more, but there's only limited columns in the original data frame, and there's only a couple features that we could engineer. But if we can have more features, obviously our model can be more robust. Then we also ran into some hardware limitations. There are some things that we wanted to implement into our model, such as hyperparameter tuning on random forest regression, but we couldn't really do that because that is simply too much computational cost. And also the problem of target class imbalance in our data set is still a problem. We try to use various approaches to combat the issue of target variable imbalance on our model, but still it didn't really work out well, as you can see in the matrix. And also this dataset can just simply be hard to obtain because there are more mediocre hotels in the world than highly rated hotels. So, that could be something that just simply cannot be bypassed. But some things that we can do are, for example, try to join more datasets onto our dataset to get more new features and be able to feature engineer more columns, such as things like weather and seasonal data, as well as customer reviews on each model and vector embeddings of these text customer reviews. We can also choose more robust model architectures and approaches, such as incorporating a deep learning framework or a artificial neural network approach in our modeling approaches, and ensemble these models in some ways. That's something that we can do. And last but not least, just having a more balanced data set can really help if someone can, actually make that data set. But yeah, this is our project, and thank you very much for listening. We hope you learned some things about the hospitality and the hotel industry. Thank you.